Hi everyone, welcome you all to this lecture about Banker's algorithm. This is C. Karpagavalli, Assistant Professor, Department of Artificial Intelligence and Data Science, Ramco Institute of Technology, Rajabalayam. The Banker's algorithm is mainly used to detect deadlock in a computer system. Before getting to the topic, we need to understand what is deadlock. Deadlock is a situation that occurs in a computer system when two or more processes are blocked and waiting for each other to release resources. It is a serious problem in operating systems as it can cause the entire system to freeze or crash. Therefore, detecting and resolving deadlock is crucial for the smooth operation of any computer system. Deadlock detection algorithms are mainly used to identify the presence of deadlocks in computer systems. These algorithms examine the system's processes and resources to determine if there is a circular wait situation that would lead to a deadlock. If a deadlock is detected, the algorithm can take steps to resolve it and prevent it from occurring again in the future. In deadlock detection algorithm, we have two categories. One is single instance of resources, another one is multiple instances of resources. If it is a single instance of resources, we can apply wait for graph and resource allocation graph to detect the deadlock. If it is a multiple instances of resources, we can apply Banker's algorithm to detect the deadlock. These are the three types of deadlock detection algorithms. One is resource allocation graph, and the second one wait for graph, third one Banker's algorithm. So here the first two resource allocation graph and wait for graph are mainly used for single instances of resources. The Banker's algorithm is mainly used for multiple instances of resources. So in this section we are going to learn about Banker's algorithm. Purpose of deadlock detection algorithm. This is mainly used to identify and resolve the deadlocks in a computer system. By identifying the occurrence of a deadlock, determining the processes and resources involved, taking the corrective action to break the deadlock and restoring the system's normal operations. The algorithm plays a crucial role in ensuring the stability and reliability of the system by preventing deadlocks. This figure shows the deadlock condition in a computer system. So in this figure, we have two processes, namely process 1 and process 2, and two resources, resource 1 and resource 2. Here the process 1 is waiting for the resource 2, but the resource 2 is assigned to the process 2. This is one case. In second case, the process 2 is waiting for the resource 1, but the resource 1 is assigned to process 1. So this shows the circular wait situation in this system. So here none of the processes can be executed because these two processes are waiting for each other to release the resources. This situation is called deadlock. In Banker's algorithm, we have two categories. One is safety algorithm, second one resource request algorithm. Let's start with safety algorithm. So in this example, the system contains 5 processes P1, P2, P3, P4 and P5 and 3 resource types A, B and C. So here the resource type A has 10 instances and B has 5 instances and resource type C has 7 instances. So this is the given data. So here in this given data we need to understand what are all the informations are given. So here the processes are P1, P2, P3, P4, P5. 5 processes are given. Then each process is having their allocation as well as the maximum of resources. Here the meaning is already we know that this is the 3 resource types, that is capital A, B and C. These are the 3 resource types. So here the allocation for the particular process P1 is 0, 1, 0, which means here 0 instances of resource type A and 1 instances of resource type B, then 0 instances of resource type C is allocated for the process P1. This is the meaning for this first number 0, 1, 0. Then maximum, so here 7 instances of resource type A, 5 instances of resource type B, 3 instances of resource type C is the maximum resource types for the process P1. So here the meaning is, from this maximum, initially 0, 1, 0 instances are allocated for the process P1. So the same way the process P2, here the allocation is 2, 0, 0. Here 2 instances of resource type A, 0 instances of resource type B, 0 instances of resource type C is allocated for the process P2. So the maximum resource instances are 3 instances of resource type A, 2 instances of resource type B and 2 instances of resource type C. So here we should not read it as whole number 322. So we should read it as 3, 2, 2 because each instances are from different types of resources. So here the process P3 allocations are 3, 0, 2. Then the maximum instances of resources are 9, 0, 2. Then P4 allocation is 2, 1, 1. Then maximum instances are of each types are 2, 2, 2. Then the process P5, here the allocations are 0, 0, 2. Then the maximum resource instances are 4, 3, 3. So here 4 instances of resource type A, 3 instances of resource type B, again 3 instances of resource type C are allocated for the the maximum resource type for the process P5. So from this maximum, initially 0, 0, 2 instances are allocated for the process P5. So these are the meaning for these allocation and maximum. Then available also given. So here the available 3 instances of resource type A, again 3 instances of resource type B, then 2 instances of resource type C. These are the available resources for the process P1 to P5. So from this initial input or initial information, we are going to apply the Banker's algorithm in order to check whether the system is safe or not. So first step, we need to find out the need matrix. So in order to find out the need matrix, we have one formula: need of I is equal to maximum of I minus allocation of I. So here from the process P1, we need to find out the need matrix. So here the maximum of P1 is 7, 5, 3. So these values can taken from the input data. Then allocations also we can take it from the input data. So allocation of particular process P1 is 0, 1, 1. So these values are given. Here the allocation 0, 1, 1, then maximum 7, 5, 3. So by subtracting this allocation from this maximum, we will get the need for the particular process P1. So likewise, we need to calculate the need for process P1 to P5. Just subtracting this allocation from this maximum. So here the process P2 maximum is 3, 2, 2, allocation 2, 0, 0. Here the need of P2 is 1, 2, 2. Just subtracting this allocation from the maximum. Then P3 maximum 9, 0, 2. Then allocation 3, 0, 2. Then need is 6, 0, 0. Then P4 maximum 2, 2, 2. Allocation 2, 1, 1. Then need for P4 is 0, 1, 1. Then final process P5 maximum 4, 3, 3. Then allocation 0, 0, 2. Then the need for particular process P5 is 4, 3, 1. So now we found out the need for each and every process from P1 to P5. So this is the need matrix for the corresponding process. So by using this need matrix, we are going to proceed for the next step. So now we are going to check whether the system is safe or not by applying the safety algorithm. So already we know that the available resources are given. So the available resources are 3, 3, 2. The resource types are capital A, capital B and C. So now we will check if each type of resource request is available for each process. So now we are going to proceed from the process P1. So take the process P1. So in this stage we are going to check one condition. So we need to check whether the need of the particular process P1 is lesser than or equal to available or not. So if the condition is true, then we can make the particular process to enter into the save sequence. Otherwise, the process P1 needs to wait until the required resource is available. So here the need for process P1 is 7, 4, 3. This value can taken from the need matrix. Then available also given 3, 3, 2. So here the condition is false because 7 is greater than 3. Again 4 is also greater than 3. So now the condition is false. So in this stage, the process P1 needs to wait until the required resources available. So we need to move for the next process P2. So second process P2. So here also we need to check whether the condition is true or false. So here the need is 1, 2, 2 and available is 3, 2, 3, 3, 2. So now the condition is true because 1 is lesser than 3, again 2 is lesser than 3, and then 2 is equal to 2. So condition is true. If the condition is true means the particular process can able to enter into the save sequence. And other thing we need to do, if the particular process entered into the save sequence means we need to update the available values. So there is a formula for updating the available resources. So here the formula is current available plus allocation of this particular process, allocation of P2. So here the available value is 332. Then allocation of P2 is 200. So these numbers, these values can taken from the input matrix, input value. So by adding these two values, we will get the new available resources 532. So once the process entered into the save sequence, we need to update the available resources. So likewise, we need to do these steps for all the processes. So now we go for the process P3. So here the process P3, here we are going to check whether the condition is true or false, whether the need of P3 is lesser than or equal to available or not. So here the need is 600, then available 532. So the available is, we can take it from the new available value because after entering the particular process into the save sequence, we are updating the available value. So this available updated available value only we need to consider. So here the need is need for particular process P3 is 600. So this value can taken from the need matrix and current available 532. Here the condition is false because 6 is greater than 5. So if any one of the resource type is false means in the entire condition is false. We should not consider it is a whole number 600 or 532. We should read it as 6, 0, 0 and 5, 3, 2. So if now the condition is false, so the meaning is the process P3 cannot enter into the save sequence. So the process P3 needs to wait until the required resources available. So next we move on to the next process P4. So here we need to check the condition. So need for the process P4 011, then available current available 532. So now we need to check whether the condition is true or false. 0 less than 5, 1 is less than 3, again 1 is less than 2. So now the condition is true. So in this stage we can make the process P4 enter into the save sequence. So after entering the process into save sequence, we need to update the available resources by using the formula available plus allocation. So here the available, current available is 532 and allocation of P4. So allocation of P4 value can taken from the input value 2, 1, 1. So this is the allocation of P4. So just adding these two value, we will get the new available resources 5, 3, 2 plus 2, 1, 1. The values are new available resources are 743. So next we can move to the next process. Next process P5. So here we need to check the condition need less than or equal to available or not. So here the need is 431 and available is 743. Now the condition is true because 4 is lesser than 7, then 3 is again lesser than 4, 1 is lesser than 3. So now the condition is true. If the condition is true means we can make the particular process can enter into the safe sequence. So after making the process into the safe sequence, we need to update the available resources. So here the current available 743, then allocation of P5 can taken from the input value 0, 0, 2. So just adding these two values, we will get the new available resources 745. So this is the last updated available resources 745. So after making this process P5 can enter into the safe sequence, we can move to the next process. Already two processes are waiting, process 1 and process 3. So in initial checking, the process P1 and P3 is violating the condition. So these two are waiting for the required resources. Now in this stage we can check the condition for the P1. So here the need for P1 is 743 and available is 745, current available 745. Now the condition is true because 7 is equal to 7, again 4 is equal to 4, 3 is lesser than 5. So now the condition is true. In this stage we can make the process can enter into the safe sequence. So once the process entered into the safe sequence, we need to update the available. So here we are updating the available is 745 and allocation 010. So new available resources are 755. So in this stage we can move to the next process. So next process P3 is also waiting for the required resources. So now we will check whether the condition is true or false. So here the need is 600 and available is 755. Now the condition is true because 6 is lesser than 7, 0 is lesser than 5, then again 0 is lesser than 5. Now the condition is true. If the condition is true means we can make the particular process enter into the safe sequence. Now the P3 can enter into the safe sequence. In this stage we need to update the available resources. So here the current available 755, the allocation of P3 is 302. So already I told that the allocation of the particular process can taken from the input values. So here the new available resources are 10, 5, 5. So these are the last updated available resources. Now we will say the particular system is safe because all the processes are entering into the safe sequence. So by using this safety algorithm, we can say whether the system is safe or not. Once all the given processes are enter into the safe sequence, we can say the particular system is safe state as well as the safe sequence. So here the safe sequences are P2, P4, P5, P1 and P3. So next is resource request algorithm. So in resource request algorithm, we need to check two conditions before applying the safety algorithm. So first condition, request of I is lesser than or equal to need of I. If the condition is true means we can go for the next step, otherwise just ignore the new request. So for all resources we need to check the particular condition, request of I less than or equal to need of I. Then after that we need to check the request of I is lesser than or equal to available or not for the all the resources. So this is the second condition. If these two conditions are satisfied or two conditions are true, we can go for the third step. So in third step we need to update all the available value, then allocation values, then resource need value. So by using this formula we can do this resource updation. So available minus request of I, new request of I, then allocation of I equal to allocation of I plus request of I. This request means new request. Then need of I is equal to need of I minus request of I. So after updating these resources, we can apply the safety algorithm in order to check whether the system is safe or not. Then advantages of Banker's algorithm. So it is mainly used to prevent the deadlocks by ensuring that all the processes acquire all the required resources before execution. So already we know that the Banker's algorithm can able to handle the multiple resource types. Then it provides a safe and efficient resource allocation methods. Disadvantages: it may not be feasible for systems with a large number of processes and resources. Already we know that the Banker's algorithms mainly for different types of different multiple instances of resources. If the numbers are larger, means it may not be feasible. Then assumes that the resource requirements are known in advance, which may not be the case in some systems. It may result in low resource utilization if the resources are reserved but not used in the problem. Thank you. Thanks for watching.